Let's prove that the following two functions are equal to for all n. So if you place any number n into these functions, the result is going to be same. So since this is equality between two functions in natural numbers, we can do induction over n. So here is the first step. So at first you have to verify the base case of the induction, so we can check if this equality holds for the starting points. So we can check n is equal to 1 and check if it's correct for n is equal to 1. So basically we want to check if f1 is equal to g1. So f1 is the alternating sum of fractions from 1 to 1 over 2 to n. So basically it means 1 over 2. So this sum is going to be 1 minus 1 over 2, which is just half. Regarding the G1 is the sum of fractions starting from n plus 1, 1 over n plus 1, up to 2n. So in our case, when n is equal to 1, it should start with n is equal to 1 plus 1, which is 2, and it should end at n times 2. So 2 times 1, which is 1 over 2. Basically, we have 1 over 2, the function. So f1 is equal to g1. So in order to make it a little bit more clear, we can try to do the computations for fn is equal to 2. F of 2 is going to be alternating sum up to 1 over 1 minus 1 over 2 up to 4. So n is 2, we need to go up to 4 minus 1 over 4. So if you do the math here, it's going to be 7 over 12. And g of 2 in a similar way. So n is 2, so we would start with 3, and n is 2. And we would end with 2 times 2, which is 4. So g of 2 is going to be 1 over 3 plus 1 over 4, which is 7 over 12. Which gives us f2 is equal to g2. So in the base case, for n is equal to 1 and n is equal to 2, the functions are equal to each other. So now we need to do the induction step and prove that f of n is equal to f of k in general. The step of the induction is going to be as follows. So we would assume that n is equal to k makes the equality correct. We would assume n is equal to k is correct, and then prove that n is equal to k plus 1 is correct. So basically, if f of k is equal to g of k, we want to prove that f of k plus 1 is equal to g of k plus 1. Since every next term of this sequence adds new terms to the end of the sum, we can make a relation, we can write a relation between f of k and f of k plus 1. So if you rewrite the f of k plus 1 in terms of f of k, it should be f of k, so all the 2k terms, and then plus there will be 2 extra steps, two extra terms, 2k plus 1 minus 1, and then minus 1 over 2k plus 1. And then if I simplify this inequality here, equation f of k, and then this one is going to be plus just the common denominator of these two. So common denominator is going to be 2k plus 2, so product of these two. This one and then if I open the parentheses, it's going to be 2k plus 1, 2k plus 1, and the numerator is going to be just 1. So f of k plus 1 in terms of f of k is f of k plus 1 over 2k plus 2 times 2k plus 1. If we go to gk plus 1, it's a very similar thing. So it's going to be gk, and then what's the gk difference between gk and gk plus 1? So gk starts from k plus 1. So if we put k here, it starts with k plus 1. But if I put k plus 1, it should start with k plus 2. So k plus 1 has this extra term. The gk has this extra term. So I have to do minus 1k plus 1. And gk plus 1 will have some extra terms at the end. So that extra term is going to be 1 over 2 times k plus 1 and 1 over 2k plus 2. So that's gk plus, if you do the common denominator of these two, it's again, so these three numbers, if you do the common denominator, you will get 2k plus 2 and 2k plus 1. So as you can see, the relation between f of k and f of k plus 1 and f of k, and gk, and then gk plus 1 and gk. So since, so here is the proof. Since f of k is equal to g of k, f of k plus 1 and gk plus 1, the only difference is this extra term, which is same in both of them. So you have two equal numbers, and if you add the same number to the both sides, you would expect them still to be equal to each other. So when f of k is equal to g of k, we can claim that f of k plus 1 is equal to g of k plus 1. So by induction, we have base, it's true for f of 1 and f of 2, and by step of the induction, every next equality is going to be true.